Before Earth had oceans, before continents rose from the surface, before the first storms, the first volcanoes, or the first living cells, there was only dust.
A young sun burned at the center of a violent newborn solar system, surrounded by a swirling disk of gas, rock, ice, and ancient particles older than the planets themselves. Somewhere inside that chaos, the ingredients of Earth began to gather.
For decades, scientists believed our planet may have been built from a cosmic mixture, rocky material from near the sun, plus water-rich material from the distant outer solar system. It was a powerful idea. After all, Earth is not just another rock. It has oceans, it has an atmosphere, it has continents, magnetic fields, weather, and life.
So it seemed logical that some of Earth's most important ingredients must have come from far away. Maybe from beyond Jupiter, maybe from icy asteroids, maybe from the frozen outer regions of the solar system.
But now, new research is changing that story. Scientists studying meteorites have found evidence that Earth may have formed almost entirely from material in the inner solar system.
In other words, Earth may not have been built from distant cosmic leftovers. It may have formed mostly from local material, right here, close to the young sun.
And that discovery could rewrite one of the biggest chapters in planetary science. To understand why this matters, we have to travel back 4.6 billion years.
At that time, the solar system was not a neat arrangement of planets. It was a storm. The newborn sun was surrounded by a protoplanetary disk, a massive rotating cloud of gas and dust.
Inside that disk, tiny grains began colliding. Some bounced apart, some shattered, but some stuck together. Over time, dust became pebbles, pebbles became rocks, rocks became planetesimals, and planetesimals became the building blocks of planets. Earth was not created all at once. It was assembled through countless collisions, impacts, mergers, and violent transformations. The young planet was repeatedly smashed by other rocky bodies. Its surface melted. Its interior separated into layers. Heavy metals sank to form the core. Lighter silicates rose to form the mantle and crust. And through this violent process, the planet we now call home slowly took shape. But one question remained difficult to answer. Where did Earth's original material come from? Meteorites help answer that question. They are not just random space rocks. They are ancient records from the earliest days of the solar system. Some meteorites formed close to the sun. Others formed farther away. And each group carries a chemical fingerprint. Scientists can read those fingerprints by studying isotopes. Isotopes are versions of the same element with different numbers of neutrons. They act like cosmic barcodes, revealing where a material likely formed. When researchers compared Earth's isotopic fingerprint with different meteorite groups, they found something surprising. Earth does not appear to contain much material from the outer solar system. Instead, Earth's chemistry closely matches material from the inner solar system. That means our planet may have been built mostly from the same local reservoir that produced the other rocky planets. Mercury, Venus, Earth, Mars, all born in the inner region of the sun's disk. This challenges the older idea that Earth needed a large amount of outer solar system material to become habitable. For a long time, scientists thought Earth's water and volatile elements may have been delivered by carbon-rich objects from beyond Jupiter. But if Earth formed mostly from inner solar system material, then something even more interesting may be true. The ingredients for habitability may have existed closer to the sun than we once believed. That does not mean Earth's story was simple. Water, carbon, and other life-supporting elements may still have arrived through several stages. Some may have been locked inside the local material that built Earth. Some may have been delivered later by impacts. Some may have survived in minerals despite the heat of the inner solar system. But the new evidence suggests Earth was not mainly assembled from far-away material. It was built close to home, and Jupiter may have played a major role in that.
Jupiter formed early and grew into the largest planet in the solar system. Its gravity was so powerful that it may have created a barrier in the disk around the Sun.
That barrier separated the inner solar system from the outer solar system. On one side were the rocky materials that built planets like Earth and Mars. On the other side were colder, carbon-rich materials from farther out.
If Jupiter blocked most of that outer material from moving inward, then Earth's formation was shaped by a cosmic wall. A giant planet may have controlled what our planet can become before Earth even fully existed.
That is an incredible possibility, because it means Earth's origin was not just determined by dust and gravity, it was also influenced by the architecture of the entire solar system. Where Jupiter formed, how fast it grew, how it shaped the disk, how it separated materials, all of these events may have helped decide the final composition of Earth.
And that leads to one of the biggest questions of all. If Earth formed mostly from local material, how did it become so rich in water? This is still one of the great mysteries.
The inner solar system was hot, so scientists once assumed water would be difficult to preserve there. But this new research suggests the early inner solar system may not have been as dry as previously believed.
Some water-bearing minerals may have survived. Some volatile elements may have been trapped in rocky materials. And some of Earth's water may have been part of its building blocks from the beginning. That would make Earth's origin even more remarkable, because it means the path to a habitable planet may not require an enormous delivery from the frozen outer solar system. The ingredients for life may be able to form much closer to a star.
And if that is true here, it may also be true elsewhere. Around other stars, rocky planets are forming in disks of dust and gas. Some are too hot. Some are too cold. Some are too massive. Some are destroyed by collisions or stripped by radiation. But some may form in just the right place, with just the right materials, under just the right conditions. If Earth's water and life-supporting elements came mostly from local material, then scientists may need to rethink how common habitable planets could be.
Maybe Earth is still rare, but maybe the ingredients that made Earth possible are not as rare as we once thought.
That is why this discovery matters. It is not just about rocks. It is not just about meteorites. It is about the origin of the only known living world in the universe.
Every ocean wave, every mountain, every cloud, every forest, every breath we take traces back to the ancient material that built this planet. And now, science is revealing that those ingredients may have come from much closer than expected.
Earth may not be a planet made from distant cosmic fragments. It may be a planet born from its own neighborhood.
A world built from the dust of the inner solar system. A world shaped by impacts, gravity, heat, and time. A world that somehow became blue and alive.
So when we ask where Earth actually came from, the answer is more powerful than we imagined. Earth came from dust orbiting a newborn sun.
It came from violent collisions in a young solar system. It came from local rock, ancient chemistry, and billions of years of transformation. But in a deeper sense, Earth came from the universe learning how to build a home, and that home became us.
This is infinite science, where the universe gets a little clearer, one discovery at a time.